through problem number 12, where we are taking a written out chemical reaction equation and we're converting it over into a BCA table. So we're figuring out exactly how much of these compounds do we have. The balanced equation, as you can see here, is 2 molecules of dihydrogen sulfide plus 3 molecules of oxygen gas produces 2 molecules of sulfur dioxide and 2 water molecules. We have in the boxes in the model here the molecules that are reacting beforehand and the molecules after the reaction has occurred. Let's just go ahead and start filling in the BCA box here. Now, right away, I know 2 numbers that we can fill in, which is the product side in the before boxes. Because remember, this is before the reaction has occurred. So before the reaction starts, we don't have any sulfur dioxide or water. So I'm going to mark these with zeros because we have 0 molecules of SO2 or water. Before the reaction occurs in the reactants columns with the H2S and the O2, let's count. It looks to me like we have 1, 2, 3, 4 molecules of the H2S, so I'm going to put a 4. And then we have 1, 2, 3, 4, 5, 6, 7, 8 oxygen molecules. So I'm going to put 8 there. Now, we have the change. So, let's see. We have enough, right? We have more than 6 oxygen, which means that we will use all 4 of our H2S, because for every 2 H2S that we use, right, we use up another 3 oxygen. So I'm just going to mark those there. So we are going to have minus 4 H2S. It looks like, oh, I guess I forgot to mark these. Let's go ahead and mark through these. So we get 2 more H2S, 3 more oxygen. So it looks like all of the H2S is used up, and we have 2 oxygen that will go into the product side remaining that are unreacted. That also means, right, that we have minus 6 O2, because we have 3 for every 2 of the H2S. So if we have 4 H2S, that means we have 6 O2 reacting. Now we go over to the product side here, and during the reaction, right, what is the change? How much are we making here? We have, let's see, 1, 2, 3, 4 SO2s made. So I'm going to put plus 4. And water, 1, 2, 3, 4 plus 4 water. And then we just do the math to figure out the after column. So we started with 4 H2S. We used all 4 in the reaction, so we would have 0 molecules of that left. We started with 8 oxygen molecules. We used up 6. There are still 2 oxygen molecules left, and if you look in the product box, you'll see we have 1, 2 oxygen molecules left. 0 plus 4 molecules that were created is just 4. And again, for water, 0 plus the 4 water molecules we created is 4. So that is a completed BCA table. Now, I have 2 more questions that I've added on to this assignment that ask you to think about if instead of the number of molecules, right? What if this was moles? Because the BCA table can also measure moles, right? Just like we can scale up a reaction equation to say not 3 moles of 3 molecules of oxygen, but 3 moles of oxygen molecules. We could say we started with 4 moles of H2S and 8 moles of oxygen, and then we created 4 moles of SO2 and 4 moles of water. So I'm going to ask you to take our stoichiometry numbers and tell me how many grams of SO2 do we end with and how many grams of H2S did we start with if those were in moles. I'm going to leave that to you to calculate. What you may think, right, is to use a BCA table like this in our future stoichiometry problems, because this can help you keep track of how many moles you have, and you can do something like this as opposed to carrying out lots of different conversions, because I know that those aren't some people's favorites. So this is an easy way to track how many moles you start with and how many moles you end with of certain compounds. So I hope this helps you, and it's a different way to do it.